Today, we're going to dive into the incredible story of a brilliant scientist, Subramanian Chandrasekhar, and the discovery he made that literally unlocked the final fate of the stars. You know, it's one of those huge cosmic questions, isn't it? We look up at the night sky, we see all these giant burning balls of gas. But what happens when they finally run out of fuel? How does a star actually die?
Well, the answer to that massive question didn't come from some huge observatory or a team of famous astronomers. Nope. It came from the mind of a young Indian scientist who was about to change everything we thought we knew about the universe.
So our story starts right here. We're going on a journey into the life and death of stars and the amazing person who figured out all their secrets. So let's meet our main character. Subramanian Chandrasekhar was born back in 1910 in Lahore, which at the time was part of British India. Even as a kid, he was just completely fascinated by math and science. It was a passion that would eventually take him all the way to the famous University of Cambridge to study, you guessed it, the stars.
Okay, so this is where things get really interesting. It's on his trip to Cambridge that something pivotal happened, a moment that would change not just his career, but the entire field of astrophysics forever. I want you to just picture this for a second. He's not in some fancy high-tech lab. He's on a ship, making the long voyage from India to England. And it's there, surrounded by nothing but the ocean, that he starts crunching these incredibly complex numbers and comes up with a truly groundbreaking theory about how stars die.
And here's the kicker, the part that's just absolutely mind-blowing. He was only 19 years old when he did this. Just think about that. A teenager, on a boat, casually figuring out the fate of the entire cosmos. It's just, wow.
So what exactly was this incredible idea he came up with? Well, today it's known as the Chandrasekhar limit. And believe me, it is a cornerstone of how we understand the universe.
All right, let's break it down. In simple terms, the Chandrasekhar limit is a cosmic tipping point. See, when a star like our sun runs out of fuel, it collapses down into this super dense, stable core called a white dwarf. This limit is the absolute maximum weight, or mass, that a white dwarf can have before it just can't hold itself up anymore and collapses under its own gravity. And that tipping point, that cosmic line in the sand, is a very specific number, 1.4 times the mass of our own sun. This one number is the ultimate decider. It determines everything that happens next. So based on this one limit, a star has two completely different destinies. If the core that's left over is less than 1.4 times the sun's mass, it gets to retire peacefully as a stable white dwarf. But if it's greater than that limit, gravity wins the fight. The star just can't support itself, and it goes out in a blaze of glory. It collapses violently into an insanely dense neutron star, or maybe even a black hole. And that collapse, that's what we call a supernova. The very explosions that created and scattered all the heavy elements, like the iron in your blood, all across the universe. Now, you'd think a discovery this huge would be celebrated immediately, right? Parades, confetti, the works. But that is not what happened at all. Chandrasekhar's idea was so out there, so revolutionary, that it actually led to a pretty tough period of struggle for him. At its core, what Chandrasekhar was saying was that the future of a star isn't some random event. It's set in stone. It's predetermined by its mass. There was a physical law, a hard limit, that dictated its final chapter. But this idea was fiercely shot down by one of the biggest names in science at the time, Sir Arthur Eddington. Eddington was the authority, and he just could not accept that a star could collapse so completely into nothing. He actually stood up and publicly ridiculed the whole idea, which, as you can imagine, made things incredibly difficult for young Chandrasekhar.
I mean, can you even imagine that? Having your most brilliant work, this incredible insight, just dismissed and mocked by the leading expert in your field? It was a massive professional setback. But here's the thing about Chandrasekhar. He was resilient. He knew his math was right, he believed in his theory, and he absolutely refused to give up on it. And you know what? His perseverance completely paid off. This next chapter is all about his ultimate victory and the incredible legacy he created.
So Chandrasekhar eventually moved to the United States. He spent decades continuing his research at the University of Chicago. And then finally, in 1983, decades after that boat trip, the rest of the world caught up to him. He was awarded the Nobel Prize in Physics for the very same theory he came up with as a 19-year-old kid.
And that really gets to the heart of his impact.
Subramanian Chandrasekhar completely changed how we see the cosmos. He's the one who taught us that stars aren't just these timeless, unchanging lights in the sky. They have life cycles. They're born, they live for billions of years, and in the end, they have a destiny that is literally written in the laws of physics. His life really leaves us with this incredibly powerful idea. It's a real testament to the power of just having conviction and sticking to the truth no matter who's pushing back. It shows us that if an idea is right, even if it gets rejected at first, it will eventually find its moment to shine, just like the stars he dedicated his life to understanding.